Okay, we're back. This time we're going to talk about the shorter assignment that had to do with the Electroscope Lab. We started in class, but didn't quite get to finish because of ending a little bit abruptly. So maybe we should talk a little bit about what's going on in this lab and what I was expecting for the answers to these cases. Again, maybe if you want to take a look at what the case is and then pause the video and try it on your own, that would be a good idea. Okay. Electroscope is reminding you is a device used to measure the presence of charge in a region. So if you have an object that's charged, it will show up somehow, and we'll talk about how this works. An electroscope is generally a device that is a conductor that has a knob made of metal, and then in the bottom part there are these gold foil leaves that if there's a presence of charge on them, there would be the same charge and they would repel. So you have a knob and the leaves. And so the question is, what happens in the electroscope when you do different things in the lab? So the first case that I wanted you to describe in your own words was, what would happen if you had this uncharged electroscope and you happen to bring a negatively charged rod nearby? And so pause it, think about it. Now we're back and we take a look at, you would expect within the electroscope that's uncharged, there's an equal number of positive and negative charges throughout. But in this case, the negatives in the top are probably going to start moving down. So the electrons themselves are going to migrate down. So the electrons move down. So that's the first thing I want to say. As they go to the bottom, you would have more negative charges on the leaves. They will then separate. So that word is supposed to be separate. So the leaves separate. What happens on the knob then? The knob is going to end up more positive. Because of the fact that the protons are more able to stay put, they don't leave because they're more bound to the nucleus. They're not going to move, whereas the electrons can move. They're lighter and they have the ability to move more readily. So as a result, the electrons are going to go down, which is going to leave the knob more positive. That's what we mean when we say polarization. There's a charge separation in the material because the electrons move down, thereby leaving more positive on the top, more negative on the bottom. The second case I wanted you to look at was the case of conduction. What would happen if you touch this uncharged electroscope with a positively charged rod? Okay, so if you want to pause, think about that. And then come back. Okay, we're going to go ahead and give this a shot now. You have equal numbers of positive and negative charges throughout. What's going to happen is the electrons are going to want to come onto the rod. So in this case, the electrons transfer to rod. It neutralizes some of the charges on the rod, that thereby losing electrons, there's more charge of positive on the electroscope. Okay? So in that case, you would expect more charge to be there as well as on the knob, because now all of a sudden we have more negatives on the rod. So the whole of the electroscope, both the knob and the leaves, are positive. Okay, so if I see that, both the knob and the leaves are positively charged. Okay, so that case 2 represents conduction of charge. the charges leave to neutralize the rod, thereby leaving the electroscope with more positive charge. The last case I'm going to have you take a look at is, how about if you bring a negatively charged rod near an uncharged electroscope and charge it by induction with grounding. So think about that for a second, pause, and come back. Okay, now we're back. This process takes 4 steps, and that is, you bring it nearby, then you touch it, which is thereby giving a grounding mechanism. So there is a charge mechanism so the charge can flow. And then if you take the grounding mechanism away and take the rod away, you're left with charge on the electroscope. So how does that work? Well, if you thought about it for a second, this negative charge, abundance of negative charge, is going to cause the electrons to want to go out to the ground. So electrons move to the ground. If that's the case, then what happens on the electroscope is it leaves the electroscope with more positive charge throughout. So positive charge is left on the electroscope. That includes the knob and the leaves. That is true in grounding. If you brought a positive nearby, the opposite would be true. The electrons would want to be attracted in from the ground. But there's always, with the grounding mechanism, a process or a pathway for these electrons to move. And in this case, they move out because they're repelled by that charge on that rod, and you end up with a positive charge on the electroscope. I hope that makes sense, and I hope the lab is clearer than it was before we left. Stay safe. I hope you're having a good day.